Good morning, class. Today we're going to be talking about Windows Presentation Foundation, or WPF. This is one of the many desktop application development libraries that Microsoft has made available to us. It's a bit different than what you've seen before in terms of Windows Forms. So let's go ahead and dig in and just talk a little bit about some of those differences. So the first big difference you'll notice, or similarity, we'll start with similarity. We have a graphical editor that's showing us what our control looks like. So this is very similar to Windows Forms, and then it shows you a preview, and you can do some editing directly there. Now, what's different is this design view down here. This is a special form of code called XAML, which stands for Application Markup Language, and it's based on XML, as is HTML. So this will look very familiar if you have done much web programming. But the real idea behind XAML is it gives us a templated form of laying out what the control looks like. And this is actually very similar to how most of the native mobile development environments work now, that they're all using a XML-based markup language to actually lay out what this page should look like. So it's important that you understand this, not just for WPF, but because it's used across the range of products for compiling down to build a user interface. This is really the new style of user interface. This is a departure from what you've seen before. Now, if you remember, when you were working with Windows Forms, you did have a code behind file, which was a partial class. And this is important to understand what a partial class actually is. And so in C# we can define partial classes. That just means that we're defining the class in two different files. So in this case, the code behind file, which is the XAML.cs file, and then the XAML file itself. In Windows Forms, you also saw that. You could go in and look at the auto-generated file, which is the C# code. Now this XAML compiles down to C# code and becomes the other half of our partial class. And that's one of the interesting things about XAML, is that technically this is defining a class. That's why it says class equals shoppinglist.main window here. This is the other half of that partial class. Also, you'll notice these XML in S. That stands for XML namespace. So that is a namespace declaration. It's the XML way of declaring namespaces. But notice that here it provides a link to a URL where that namespace is actually defined. And then there's one here that's actually very interesting. XMLNS local is defined as corresponding to CLR namespace shopping list. And if we go to our code behind, you also see our namespace is shopping list. And this is actually linking those two namespaces together. So the XML and the C# namespace. The CLR stands for Common Language Runtime, which is the virtual machine on which our .NET applications actually run. So it's saying that I want to link to a namespace that's defined in the Common Language Runtime, and that namespace is called shopping list. So local here refers to our local shopping list. And you can define as many of these as you want, and we will actually be doing that a little bit further along the line. But it's important you understand how those are linked together, because that will come into play before too long. Now, what we're going to build today is a simple shopping list application where we can add items to a shopping list, and we'll display them in a list form. So a very, very simple GUI application just lets us explore some of the concepts that exist in WPF that are a bit different than what you've seen before. So to start with, we do have a line item data class. This is much like the other data classes you've written up to this point. It's a public class. It has a couple of properties. The name property is a string. It has a quantity, so how many you want to buy of an item. And then it has an isFound Boolean, which we'll eventually use to do a check box next to our line items. So we can say, I want 5 cans of tomato soup. And then when you're at the store and you see your tomato soup and pull it off the shelf and put it in your cart, you can check that off your list. So we're giving kind of all these different pieces are already built into our data class. Now we just need to pull those ideas across into our GUI. And we'll actually do this in multiple stages. So part of this we'll do today, part of this we'll do as we introduce other WPF concepts and drill down a little bit more into those. So first of all, let's jump back to our main window. So one of the big ideas behind WPF is it's a component-based design. So rather than putting everything in our main window, which we can do, what we're going to do is actually add components to that. And the first component that we're going to add is actually going to be our shopping list view, our shopping list control. So let's go ahead and create a new control here, and we will go ahead and say we want to add a new item. And let me find it. Where you at, Ed? Sorry, I've been looking at studio lights and they are very bright. Okay, so we're going to come in and notice we have different options that are WPF related here. Window, which creates a new window, and generally with an application we only want one window. It is possible to have a multi-window application. That's not generally what we're after unless we have a very specific use case. So for now you can ignore that. Page is for doing something that looks more like a traditional web app where you have pages you can flip between. We're not going to be using those just yet either. What we're going to do is this user control. And notice that it tries to call it user control 1. We're going to give it our own name. So a shopping list control. It'll take a minute to generate, and boom, there we have it. So a couple things I want to show you here. First of all, this design height and design width, that affects how big it is displayed up here. And I want kind of a traditional shopping list where it's a long, thin list. So I'm going to change this design width to 400 and maybe even 300. Let's see what that looks like. Yeah, I like that shape. Now another thing you'll notice here is it's very hard to see our control. This little checkbox icon here toggles an artboard background, which will help us actually see what's on our control. That's important because some of our controls have a transparent background, and if we have black text on a transparent background on a black background, it becomes very difficult to see what we're doing. One of the other things you might play with, depending on your screen orientation, these buttons over here will switch between a horizontal and a vertical view. And since I'm doing this as a narrow list, it makes a lot of sense to do my coding this way. And I can go ahead and recenter that. I have these, what really look like HTML elements, which you guys were introduced to back in 1.15, where the grid is a layout element, and I can put different things in there. I'm not going to actually use a grid here. I'm going to use a dock panel. And a dock panel is basically allows you to dock something at the top, the bottom, the left, or the right, and you can just kind of add as many things as you want. For right now, inside that dock panel, I'm only going to be defining one thing, which is going to be the actual shopping list. I'm going to use a pre-built component called a list view. And that's going to show us a list of items. And notice this looks very much like HTML. Here I have a self-closing tag because I don't need to put anything inside the list view just yet. And the dock panel, I have an open and closing tag, and it's enclosing that list view. So like I said, this took a lot of inspiration from HTML. So we're going to see a lot of this style of definition. And what I'm actually saying here is I have a control. Inside that control, I have a dock panel. Inside that dock panel, I have a list view. And each one of these is its own component. This is where component-based design comes in. We're actually creating components, nesting components inside components, and we're composing the entire application as kind of this nested hierarchy of components. Now, the other thing I would want to do here is I want to have this list view display all of the items in my list. And I can go to the code behind, give this list view a name, and attach something to it. And what I want to attach to is the item source. But I'm going to actually show you a little preview of some of the power of WPF. And what I'm going to show you is a little bit of binding. And we're going to come back to data binding. We're going to explore it in much more depth. But for right now, we're going to jump to our code behind for the main window. And right under this initialize component, we're going to set a data context. The data context is a property that actually exists on everything in WPF. So all the WPF controls have a this.data context. And the this, of course, is optional. So if you like to see it there, You can add it, you don't have to have it, but we're going to set this data context to be, in our case, a new list, and we're going to put in a list of those shopping list line items. So line item, and that, whoops, I put my E in the right spot. There we go. So that is now assigned to the data context of the shopping list. Now what's really interesting about this is the idea of an elements tree, and we'll come back to this elements tree idea as well, but basically this is an elements tree starting at the window. This window contains a grid. In that grid, I'm going to add a shopping list control, which comes out of that local namespace. So in order to use it, I have to use the local namespace, and then notice it offers that the shopping list control exists there. So nested inside now I have a shopping list control. And I'm also going to change the width here to reflect kind of what we put the shopping list to be. This is going to be 300. Now up here, this is the actual width of the main window. The main window is the only control we actually set the actual width and height, or normally it'd be the only one. Because everything underneath that we want to resize to fit the size of the container. And that's important because if we allow it to resize to fit the size of the container, if somebody stretches this window or shrinks this window, our control is going to actually mimic that. Now, also you'll notice that right now it's telling me I can't render this because it does not exist in the namespace. You might be wondering, what does that actually mean? Well, in order for things to be rendered up here, we have to actually have compiled or built our code for this rendering control to know what it looks like. So even though I've defined it, I haven't compiled it. The DLL does not exist, and it does not contain this control. So this is an important thing to know about WPF, is that we have to build every so often in order for it to be able to display things in that display window. And that is a little bit different than what you're used to from Windows Forms. But notice now that I've built it, my window shrinks. I have the shopping list being displayed there, which of course there's nothing in it yet. But we start getting the view of what that looks like. Now let's jump back out to our shopping list control. And if we look at its XAML, it has at its upper level the shopping list. Inside that we have a dock panel. Inside that we have a list view. And this list view, we can manipulate it from the back end if we give it a name, but we can also manipulate it directly in here, and we can define a particular property. For example, the items source property determines where it's going to get the things it's supposed to display. And we're going to set this, and this is the special code for a binding. We do inside a string of curly brace, binding, and then we supply a path, and we're going to point this. Actually, we're just going to do binding, just like that. And the reason, binding, not binding. What this is saying is I want to bind to my data source. So the items in the list are going to come from the data source, and that data source is actually going to be the one we've defined here, this list of line items. Now we've defined this at the top of that elements tree, but we can access it all the way down, because if we don't define a data source at any step in that hierarchy, then every step in the hierarchy uses whatever its parent's data source was. So walking up that list, we start here with a shopping list control. We say we're going to bind to its data source. It says, okay, dock panel, what's your data source? And dock panel says, well, I don't have one. So I'm going to use my parents, which is the shopping list class. And it says, well, I don't have a data source, so I'm going to use my parents, which brings us into the grid in the the main window. And the grid says, well, I don't have a data source, so I'm going to use my parents, which is the window. In the window, we set the data context. So that data context now becomes the data context for the window and for everybody down that chain until we replace it with something else somewhere along that chain. So right now, our shopping list is going to be displaying whatever is in the shopping list control that is defined, or whatever's in the main window inside its data context. So let's actually prove that. If we go back to our main Windows code behind, where we've defined this list and say we want to add something to it. Now there's a challenge, because if I say data context dot add, we know it has an add method. But data context type is actually an object. So it's being cast all the way back to an object, and it can only use the properties of an object. And data context, or an object, does not have an add method. We know it does because it's list, but we can't use that. So one of the ways we can get around this is we could cast this to be a list of line items. And we have to do that cast before we invoke the add. So we'd have to wrap this in a parenthesis before our period. And suddenly it will stop complaining. Well, actually, it will want to have the item that we're adding. So we'd say a new line item. And we're going to go ahead and give it a name. And we'll go ahead and put in eggs, because eggs are a big thing right now. So we'll put in eggs, and this will work. So let's go ahead and run this, and we should see when we run this that our main window pops up, and then we should have our one item in our list, and there it is, shopping list line item. Now, there's a couple things we want to do here. First of all, the shopping list dot line item, you might be wondering, what exactly is that? Well, if we think about it, if we go to our shopping list line item here, shopping list is the namespace, line item is the class. And that is a default with C# is that the toString method will always return, or at least unless you override it, will return the fully quantified name of the class. So all the namespaces it's in, then the name of the class. And that's what we're seeing here, is because this list needs to display a string, it's saying, okay, I'm going to invoke the toString because you're an object. I don't know how to display you, but I know you have a toString method, so call your toString, tell me what I should display. I'm going to display that. Now, this is clearly not what we want to display. So a quick and simple fix, which is not the most ideal, but it's one that will work for right now, is to override that toString method. String toString. So every class has a toString method, and every object in C#, it's inherited from object, and we can always override that. And notice down here, this base toString, we haven't really talked about this much, but base just means I want to invoke a method on the base class. So this actually is kind of like a pass-through, kind of like what we did in our last milestone, where it's saying, okay, I'm going to call the base methods toString and pull that value in here. Of course, that's not what we want to do, but if you ever need to access one of those base classes methods, that's how you do it in a derived class. So what we're going to do here is we're going to actually return our name property, and therefore it should display our name. And we'll go ahead and run this again. And now notice our list is showing eggs. So we have our eggs showing up properly. Okay. Now there's one other thing I'd really like to fix here, and it's not necessarily an error, but it's something that's maybe not the most ideal way of doing it. So this casting works, but A, it's ugly, and B, it's a little bit risky because if this data context is not a list, then this casting will fail, and it will fail throwing an error, an exception, which will take down our whole program unless we enclose it in a try, catch, and handle that error. And this is not ideal for a couple different reasons. Now, it's okay in this case because we know this has to be a list because we just declared it as a list. But if we add a whole bunch more code in here and somebody else adds code, there may come a point where that starts to diverge, and suddenly somebody changes that data context to a different kind of object, and this will now crash our code. So one of the things we can do is we can test if our data context is a list of line items. And once we know that, then we can do this cast with confidence. However, there is some syntactic sugar, because this became something that people did a lot, that can actually simplify this a lot more. And we can just add a variable name in here, And inside the body of our if statement, that variable name is now going to be our data context having been cast to be that type. So the list again, the casting has already been happened, and we assign it to that variable list. So this part has already been done for us and assigned to our list. And if this casting is not possible, if this is not a list, this evaluates to false and will actually skip right over this. So we will only add eggs if that's something we can possibly do. This will avoid any of the exception possibilities, and it will just work. And if for some reason this data context has been changed, then we won't actually do any of this code, which is generally a little bit safer than throwing an exception. The downside is asking it to add something that's going to silently fail. It's not going to actually happen. And you might be wondering, well, when you're running your code and you're trying something and it's not showing up, you're like, why is that not happening? Well, that's why. Okay. The next thing I'd like to do is rather than adding an item here, I want to add an item when we put type 1 into a input. So let's add an input to our shopping list control. And we want to have at the bottom of our dock panel a place where we can type in a new item to add to the list and a button we can click to actually add it to the list. And I'm going to go ahead and put that here. So an input. And the inputs in WPF, especially for text, are going to be called text box. And that makes an editable text box. There's also a text view or a text block, which gives us a non-editable display of text. I'm going to go ahead and give this a name property, and I'm going to call this, I'll call it input. And then I'm also going to add a button, and I'm going to call this button, actually, I'll just declare a button, and in this button I'm going to give it a value. Nope. We'll just give it some text inside the button, and we're going to tell that button that we want to add to list. So that's going to be the label of our button. Now notice these are showing up on the left-hand side. That's the default side that we dock to. That's not where we want it to dock, so we're going to say dock panel dot dock. So we're going to set its dock property to be on the bottom. And notice that immediately moves it to the bottom. We're going to do the same thing with the button. And notice too that they appear in the order that they've actually been declared. So our text box is below our add button. That's probably not the order we want them in. So let's go ahead and switch those. It's a little more conventional to have your text box on the top and then have your add button on the bottom. And then notice the item source is in the middle. And this is an important thing with a dock panel is the very last item expands to fill all the available space no matter where it's docked. So technically this item source is docked to the left because that's the default. But it's going to expand to fill all the available space because it's the last item we've added to the dock panel. So that's kind of what that looks like. Now, the next thing we'd want to do is we want to add an event listener here to our add item. So we're going to jump back to our code behind here. And we'll call this add item click. And with an event, a listener, we always have an object, which is the sender. And then we have an event args. And in WPF, we actually use a routed event args, which is a slightly different formulation. It adds a little bit extra stuff to our event args. And once we have this, what we want to do is figure out what our item is. So we can look at that named field, and when we give a name to a property or to a something in the WPF side, that makes it accessible as a property on our code behind. So we named it input, so we can actually reference input here, and we can say input.value, get value, or input.text actually, is going to be the text that was typed into that box. So let's create a new line item, and we're going to set its name to be that input.text. And we want to add that to our list, so we need to hold on to this. I'm going to use var item. You can also call it a line item. This is one of the areas where using the var actually is okay in coding style, because we immediately declare it and then we immediately use it. There is a newer syntax now where you declare a line item, and then here just say new, so you don't have to type out line item again. Some people really prefer that because it really enforces the idea of typing. Var, like we talked about before, means that we're actually going to infer the type from whatever we created. It's still going to always be a line item, but it determines it's a line item by looking at what we constructed and put in there. Okay, so once we have that item, we want to add that to our list. So how do we get that list? Well, remember that list is our data context. That comes all the way down. So we can actually take our data context, the data context of this class, and know that that should be a list of line items. And we can use that pattern matching casting operator that we saw just a minute ago to assign it to this list here. We can say list.add list. So we're going to list.add item. Item we just created. That's going to add a new item to our list, and we're going to take advantage of some of the features of WPF, specifically that data context, which gets passed down that elements tree. And like I said, we'll come back and revisit that elements tree soon, but it's important to know. And of course, we want to define or provide a description of our event listener, handles, or button, click, event, adding a new item to our list. And our sender is the sender of this event. And our event args are metadata for the event. All right. Now, the last thing we need to do is we need to attach this event listener. We can do this in the code behind after the initialize component. It's very important it comes after the initialize component, because the initialize component actually processes this XAML and adds all these pieces. So if you try to manipulate something before the initialize component, say you want to use the input or the button or any of those, they don't exist yet. But we can also add it directly here in our XAML. We can say that we want the click event to map to that add item click. And that's kind of my preferred way of doing it, especially if there's only going to be one event handler. If you need to attach more than one event listener to that event, then you need to do it from the code behind. But in most cases, we're only going to have one. This is actually pretty easy to do. And now if we run our shopping list again, it should, once again, display eggs. Oops. Did not. That's interesting. We don't need that, so we'll just ignore that error message for the moment. And pull back up our window. And notice it displays eggs. And if we want to add something else to the list, bacon. That should fire off our event handler, add it to the list, and have it displayed. Now, it's not showing up, and you might be wondering why. Well, let's walk through our code and see if that's actually coming into our list. So if we look at our shopping list control, we'll add a breakpoint here and run this again. And I'm going to add the list. And notice there it says, oh yeah, I am adding it, bacon there. If I step through, or step into, we will actually, oops, we skipped over it. So we could have gone to the list and actually seen that that list was adding it, but it is there. Now the problem is, it's there in the list, but the GUI doesn't know that the list has changed. And we need a method to actually tell the list that that's changing, and there is a built-in way of doing that in C# using events, specifically the collection changed event and the property changed event. And that's actually going to be the topic of our next exercise. But in the meantime, one easy fix, or relatively easy fix, is instead of using a list, we're going to use an observable collection, which is a collection that implements the property changed. But that also means that we need to change what this is. Now, one of the things we can do is we can just cast it as an I collection, because observable collection and list both implement that I collection. So as long as we treat it as an I collection, it will have an add method that will work the way we expect. And then the same thing for our code behind here. Instead of calling this a list, we're going to call this an I collection. And that should take care of that particular issue. So if we run this again, now because it implements the interface and it does the event, all of that is going to be handled automatically by the GUI and through the binding, and we'll talk more about why that works and how that works in one of our future lessons. And there we have our bacon. So we can add as many items to the shopping list as we want. And that's really where we're going to stop for now, because this gives us kind of a big picture feel for what WPF is and some of the ways that we can work with it. There is one other big caution I would like to give you. Many of you are used to dragging things from your editor, so having this toolbox open and pulling individual tools out and dropping them into here, rather than typing them like I've been doing. Now, you can drag and drop things into your control here, but there is a problem with how that does that, because what it does is it starts using margins to position things within the screen. And when we run this, it will look fine as long as you don't change the dimensions of your window. As soon as you start changing the dimensions of your window, all of that's going to end up in weird spots, because margins are not really appropriate for positioning elements. That was just the fix that Microsoft came up with to make this feel more like Windows Forms for people who are coming from Windows Forms. But it's a bad practice, so I would highly discourage it. Instead, type it in the XAML like I've been doing. You can go ahead and look at the toolbox and see what's there. But the benefit of typing it in the XAML is A, you will really understand what those controls properties are, and B, as you get good at it, you'll actually be much faster typing code than you are doing the drag and drop. That's almost a universal rule, that we're just faster at doing it that way. And you'll come up with layouts that actually look better and behave better. I would also encourage you to go back to some of your old Windows Forms apps, run them, and try resizing them like this. And you'll find out Windows Forms does a terrible job of that. Everything you define is going to be floating up here in this corner, and the rest of it's going to be open white space. And this is one of the big issues with Windows Forms. Windows Forms was really developed in a time where our monitors were a standard size, standard resolution, and therefore you didn't need to worry about different size of monitors. As we know, our modern monitors and devices, we're going to have a range of sizes, and that we really need to be aware and deal with that. So WPF gives us a better set of tools for having our controls actually size appropriately for the screen that we're putting them on. It's not perfect by any means, but it's a lot better. So just a couple things to keep in mind as you start down this path of working with WPF. So thank you for your time. We will see you soon.